When you look at the first mile aggregation, it's working with the farmers, the village level entrepreneurs. In this segment, they earn money. So from a waste stream, there is money which goes into their bank account. Bulk of it is going to the strata of society which was not included in the energy value chain. The farmer, the village level entrepreneurs, the storage ecosystem, the transportation system which gets built. There is an element of a pricing of that carbon credits which will get shared in the entire value chain. But it is a commodity now which will be bought by the polluting industries so that they can decarbonize. So if I produce biochar and I apply biochar along with the farmer to a farm field, even the farmer is going to earn carbon credit. So the sustainability practices of agriculture will also yield carbon credits. So it is imperative that the problem statement is defined. Once that problem statement definition is kind of put on paper, then solutions for it can also be put on paper, and that change management structure to be brought in. And once you start working on this, sustainable practices kick in, and then the value monetization is possible to happen.
I'd like to now invite Vishwa's founder, Shivani Mulapti, to initiate the Q&A session.
Good morning. Good morning. Namaste, Colonel Ahuja ji.
Namaste.
This is a very much needed subject for today's generation. And there's a lot of lack of awareness among people about this subject. Everybody can see waste everywhere. Everybody can see farm waste everywhere. But how to harness it, how to direct it towards a more meaningful usage is something that you have explained, and the need for it to reach to every corner of our country or the world is very important, especially at a stage when we are exploiting Mother Earth in a very big way. And perhaps there will come a time when we will not be able to reverse the damage we are creating. Yeah. Thank you so much. We will go to our first question. Mr. Shmel, would you like to ask your question?
Okay, thank you very much. Very, very interesting presentation. And I want to ask you next question. I want to ask you how sustainable energy can support resolution problems of poverty and social and economic inequality. How sustainable energy can support in improvement well-being of poor and low socioeconomic groups of population?
So thank you so much, Mr. Shamel. Fantastic question. Two things which are clearly evident, and data talks about it. When you look at the first mile aggregation, it's working with the farmers, the village level entrepreneurs who, and when I say entrepreneurs, because they work for themselves in this supply chain management aggregation. And when they do this, in this segment, they earn money. So from a waste stream, there is money which goes into their bank account for the work that they do in terms of the aggregation and storage. There is equitable sharing of wealth and resource of the value chain. So if you look at the final energy cost, let's take, for example, you take the energy cost for replacing coal in thermal boiler with farm agri residue based briquettes or pellets. And when you work backwards on the cost sharing, while there is a saving for the industry, it is cheaper than fossil fuel costs. But if you start working backwards, there is a entire value chain where this energy value gets distributed. Now, this goes right up till the farmer's pocket. So you can, from data, understand clearly that in this entire value chain of energy pricing, who is getting what, How much is the press mill getting for doing this? How much is the farmer really getting? What is the transportation system, where it is going? How much is it, whoever is working in that value chain, where in an equitable manner that sharing of the wealth or the resource is happening. More importantly, in this energy value chain, it is not that it is going to large corporates, but bulk of it is going to the strata of society which was not included in the energy value chain. The farmer, the village level entrepreneurs, the storage ecosystem, the transportation system which gets built. So this becomes where the inequality is getting addressed in the energy value chain. Secondly, when you are looking at a carbon value, and I spoke about solutions that we are building and many more are happening, in that value also there is an element of a pricing of that carbon credits which will get shared in the entire value chain, starting from the farmers in itself. So there is equal distribution, or I won't call it in terms of equal, there is an equivalent distribution of wealth in the entire value chain in who's doing what, which is tracked, which is traceable, and which is auditable in the functions that I spoke about.
Thank you very much.
Thank you. Thanks for the question.
A lot of people have been talking about carbon credits, and it is, as you also said today, it's more convertible into amounts. Can you elaborate on it?
Sure. So, madam, for the decarbonization to happen, for large scale industrialization, why is a carbon credit market available? It is available because the solutions which are envisaged to be put in place require a gap funding. These are not presently commercially viable solutions. And since they require this gap funding, how is it going to come? This is going to come from a carbon credit certificate which would get issued based on digital monitoring, reporting, verification, DMRV solutions. And if and when these certificates are issued, then these certificates are purchased. Again, it's a market, a platform market, demand and supply situations, but it is a commodity now which will be bought by the polluting industries so that they can decarbonize, which is the norm, which is the mandate, of decarbonization globally. Each country has set that target, each industry has set their targets, etc. So let's take example of the growing data center industry. With AI coming in, the data center boom is there now. If you look at this data center boom, this is energy guzzler 24 by 7, 365 days a year, and it is going to continue. How do you decarbonize this? So this energy decarbonization is also happening by purchasing this carbon credit certificates. So if you look at in the recent times, there is a new process of biochar as a product, which requires a technological intervention, and the same biomass that I showed gets converted to biochar. This biochar is a wonder material, which is science-based technological intervention conversion, SBTI conversion, which when applied to fields, farm fields, forest fields, etc., acts as a carbon sequester sink. So if I produce biochar and I apply biochar along with the farmer to a farm field, this has a long gestation period of carbon sequester. It will start taking the atmospheric carbon and putting it in the soil. And hence, it is a carbon sink and will get carbon credit certificates to be issued. What is happening where these large technology companies like Google, Microsoft, Adobe, etc., Infosys, and so on and so forth, all of them are funding this biochar production solutions in India and allowing these new age companies to come up to produce biochar, and they're actually pre-funding it to buy the carbon credits. So companies like Varad, Mashmix, we have a company called as Biochar India. All these companies today have suitors available, these large tech companies, to actually pre-fund to do these projects. So, if you pre-fund, you will sell cheaper. But if you actually do the projects and bring those credits to market, these credits are CDR credits, carbon dioxide removal credits, which are much, much higher price than the conventional carbon credits, which are replacement credits. So you get carbon credits for replacement of fossil fuel, but if you are doing CCUS, then the credits are significantly higher. And I'll just give you price point numbers. A replacement credit today, global markets is between $2 to $5 per CER, carbon dioxide equivalent removal, CER credit. But a CDR credit is in the range of $120 to $140 today. So the Googles of the world, the Microsofts of the world are pre-funding between $90 to $110 for this CDR credit in the Indian market. So look at the new age business and opportunities, in biochar, in carbon capture storage utilization. What is also going to happen is with this 20,000 crores, which is earmarked, this will be incentivized for biochar companies or science-based technology interventions, nature-based solutions, where a new age business segment will come up for carbon credit to get utilized. So somebody will have to do the measurement, reporting, verification, issuance of these carbon credits, and thereafter you will monetize it on the platform like a trading platform. You will hold these credits in a digital form, but whenever you sell, there will be a price point. So obviously, you will have variation trends, and you can sell it in the Indian market or the global market.
Is it like a stock you can sell and buy these?
Exactly. But the issuance of that stock will happen after a process of doing the action, after a process of it getting monitored, reported, verified by agencies which are mandated to do these audits. Once that happens as a process, then the issuance will happen of the certificate. Now it is like a stock which is available in a digital form, and you can trade it in the carbon credit stock market.
So basically, this is more like a little industry or a factory that people put. It's not like every farmer can come and say, okay, I'll get you carbon credits. No.
No, every farmer today is also able to get carbon credits because there is a baseline of what happens in agriculture. Agriculture per se also generates a lot of carbon in terms of CO2 and methane. And if in that baseline the farmer brings practices to reduce their carbon consumption, then the farmers are also getting carbon credits. So this is regenerative agriculture. This is progressive agriculture. And even in India today, there are hundreds and thousands of farmers where there are companies who are working with these farmers to make this change management. And once the baseline reporting verification has happened and the change reporting verification happens, even the farmer is going to earn carbon credit.
So is it for crops like rice, wheat and all, or is
Every
it
crop, madam.
mango trees?
Every crop.
How I can understand for a crop like rice, okay, you have residue which you burn that you can follow it in the right process. But for
the residue. So let me explain. Assume there is no burning of the residue. Even in that crop growing, there is a footprint of carbon in terms of, the tractor being used, the fertilizer being used, the water being used, you're pumping water, using electricity. So there is a carbon footprint of agriculture. There is a carbon footprint of animal husbandry and very high methane generation there. So that footprint is also causing, it's not only industry which causes, the global warming because of the way industries are, even agriculture causes it. So how do you reduce that footprint in agriculture? So a simple thing like if you replace a tractor diesel base with an EV tractor, then you are reducing the footprint. If I am using X amount of water and by doing certain practices, the water usage comes down, which is measured and audited, then again, there is a better practice. The use of fertilizer, if it is reduced with organic fertilizer, with change, then it is use of pesticides if it is reduced. So if you are going towards organic farming and that reduction is reported and verified, all these contribute towards now possibly, not only possibly, it is happening in India and, where this certification of carbon credit would come in. So the sustainability practices of agriculture will also yield carbon credits.
So
and obviously, who's at the center of it? The farmer. The acceptance has to happen with the farmer and the change. And thus, they are actually going to be the largest recipient of that value of that carbon credit.
Okay. Next question is from Mr. Vasant Kumar Mysore. Yes, please unmute yourself.
It was a wonderful experience for me because as an environmentalist, I was always perturbed about this carbon credit business. What's happening is a few years ago, there was a big fiasco about misusing carbon credits, and many multinational companies used it as a trading mechanism for making fast money. I don't know to what extent it is correct, but quite a few things have happened because carbon credit was a trading factor. Anyway, that second thing, sir. As you know, tobacco industry is using, particularly tobacco farmers, are felling millions of trees for curing FCV, that is flu cured Virginia tobacco from Mysore and around this belt. Every day, 15 to 20 lorry loads of wood logs are traded near Hunsur, Periyapatna, and other places. They are buying those things. We don't know exactly from which corner they come from because Coorg is very near here, but to what extent Western Ghats are also near here. And as an environmentalist and also an anti-tobacco activist, I have followed these things and found out that millions of trees are cut every year for curing millions of tobacco crop. They are burnt in barns, and government has the capacity to control them also. But they are not able to control this kind of a felling, which is totally illegal. We don't know to what extent it is legal or what extent is illegal. But it is a fact that these hundreds of lorry loads are brought every month, and they are buying. Farmers are buying and storing it, drying it, and loading it in barns and curing the tobacco crop by hanging that bunches of tobacco leaves inside the barns. There is a limit. There should be a limit for everything. And it is unfortunately nobody is bothered about such an illegal felling. And as you know, tobacco kills. It is not a good thing. FSSA has certified that it's a poison. Still, the government continues to levy some taxes, auction them in government platforms, and then become what you call culpable homicide not amounting to murder, knowing fully well that cancer, cigarette smoking or gutka, and these burning of woods are causing a lot of climate change, global warming, CO2, methane, and other. What is your view about replacing wood to help farmers to cure their tobacco with biochar or some of your products?
So thank you, sir. Thanks for your question and highlighting a big problem which you are seeing yourself. On the first part that you said in terms of the carbon credit situation, you are right. The word there was or is greenwashing. So large companies claimed to do things where they were, so to say, greening the industry. Large corporates did that globally and more predominantly towards Europe and US. And these large corporates claimed billions of dollars over, large periods of time for, showcasing that they have greened their, products. But unfortunately, it was not so. And then it got termed in those audits as greenwashing. And thus, more and more emphasis now on the reporting and verification and processing has come about. So, that's why it's not that the carbon credits today would get only issued. That's why the carbon credit market also saw global crash from numbers which were as high as between $10 to $15 per credit, went down to situations of actually no value and today between, $2 to $5 per credit. And that change now is again happening where based on verifiable credits only you would get, the benefits of it. So unfortunately, as people or, as societies, every good that we want to do, there are scrupulous elements who find loopholes and, monetization and quick money and quick bucks are made. So that has happened. Unfortunate, but, today more and more processes are trying to club that. So that's on the first part. So today, if you are going, wanting the credits from a clean business structure to do, you would have to have auditable, verifiable credits processes, and then only you will be able to get that value. On the second part, in terms of the tobacco industry, and again, it's an industry which is in a way that one of the largest revenue sources for government. While in terms of mitigating the cancer, health, etc., government does a lot in terms of taxation, etc., on each cigarette bud or a packet. And the every budget, the taxation there goes up, but the consumption has not gone down. So people still continue to consume that. And thereby the revenue for the government is increasing from the taxation. So it is about a societal change management which will be required for moving away from cigarette, tobacco, tobacco, etc., which will take significant efforts to happen. But in terms of the process in which the way that you mentioned that trees are being cut and for curing it is being used, there is possibility of better sustainable solutions to be brought. Now that is something which will need to be taken up. Again, it is about baselining the present processes and creating systems to improve that, and thereby as a change management create ecosystems for carbon credits or credits to be available for that. Very difficult for governments, regulators to control such large scale felling or changes because people do it. People are vote bank, people are following processes. Intervention from government to come and stop that maybe is not possible as a structure. So it is imperative that, since you yourself mentioned you are an environmentalist and you're looking at this and you're seeing this problem statement, so the problem statement is defined. Once that problem statement definition is kind of put on paper, then solutions for it can also be put on paper, and that change management structure to be brought in. And once you start working on this, sustainable practices kick in, and then the value monetization is possible to happen. At least what will also need to be seen is what are the present numbers for this farmer to get that log, to buy this log, what is the price point at which they are getting this. And if in that change management a solution which is cheaper than the present price point can be brought, then it's a no-brainer, it will happen. But if the price point is higher, then there is a question, why will that farmer do it and who's going to bridge this higher price point? So you will have to do this work of mapping both out, and then building projects and solutions around. There is also significant philanthropic capital available to do such things. There is large scale capital for NGOs for such sustainability build-ups, which is available. So if you can build such kind of projects, so I'll give you a simple example of a project which is happening in Nagaland. There is an organization called as IDAN, IDAN. It is an organization built in public-private partnership. Government of Nagaland is leading it. It is about the change management of forest management of the jhum cultivation or jhum farming, which the people of Nagaland do. All the land there, all the forests there is not owned by government, but is owned by community and people. That's the tribes there, and it's all tribal land. So if you have to bring change management over there, people have to get involved.
Professor Dheeraj Kumar, please unmute yourself.
Good afternoon, Lieutenant Colonel Ahuja ji. So it's the first time I'm hearing you. So I am Professor Dheeraj Kumar Mahajan from IIT Ropar, and I work extensively in sustainability, and I'm also faculty advisor of one of the prime startup called Biofield Power, which is emerging from IIT Ropar, which is basically making an Uber for biomass management only. So, and in this startup, we are working on bringing low cost solution for MRV, like monitoring, reporting, and verification of carbon projects involving biomass. So, can you give an example of MRV which will be applicable for a parali management, like which happens in November, or in biomass in general from fields in Punjab? Like what technology intervention is required if we need to set up a low cost MRV for a carbon project?
So, Professor Saab, thank you for your question.
Yeah.
I'm aware of what you're doing in your work. We do follow that.
Oh wow, thank you very
We
much.
also work with multiple more IITs and IIMs, etc.
Okay.
So, again, compliments for doing this.
Thank you.
You will need to first set up the baseline. That is very important.
Yeah.
So presently, if you look at a baseline for let's take a use case of parali management. Then what is the present practice which is happening?
Yeah.
So if you look at there are 5 steps to the parali being removed from the fields. The first is after the combined harvester has moved,
Yeah.
this parali or rice paddy straw is available in the fields in 2
Mhm.
forms. One that is thrown out from the combined harvester, and the
Yeah.
second which is still standing in the field. So the first step which is happening is cutting.
Yes.
So you put a cutter behind a tractor and run through the fields and
Yeah.
cut out the standing parali. Now
Yeah.
your entire field is with a bed of rice paddy straw which is
Yes.
thrown across the fields.
Yes. Yes.
Now this is happening using a tractor which uses diesel.
Yeah.
So how much diesel have you burnt to do this cutting operation? So that's step 1. The step 2, now you are doing raking on this bed of parali.
Yeah. Yeah.
Again with a tractor. So
Exactly.
when you're doing this raking, what is the quantum of diesel that you have used and burnt?
Yeah.
The third step that you are doing is baling. Again with that same tractor. So what is the quantum of diesel that you have consumed in this baling?
Yeah. Yeah.
The fourth step that you're doing is loading these bales on a tractor trolley system.
Yeah.
So basically low flatbed trolleys, and I am the designer of that low flatbed
Wow.
trolleys 15 years back. So all that you see all over Punjab, the first low flatbed trolley was designed by me. At that point of time, we used to move 6 to 8 tons per trolley trip. Today, our designs move between 12 to 14 tons per trolley trip.
Yes.
So again, what is the turnaround time and transportation distance from that field to the storage center, like I had showed in my photograph? So let's assume 5 kilometers as a hub and spoke model. So 5 kilometers, how much of parali moved? 6 tons, 8 tons, 10 tons, 14 tons as a number. And then in the storage, it is there. After that, in storage also, there is natural degradation of methane emission happening. How much of it is naturally degraded? And then in the use case, you are again doing a logistics to move it again on a tractor trolley system, which is the same, moving it 5, 10, 15 kilometers for industrial usage. So the base case of carbon mapping, and in this case, it is polluting carbon, you will have to do.
Yeah.
As a first case. Now come to the second part of the replacement. What am I replacing? I am replacing coal in a boiler. I am replacing LDO, furnace oil, diesel in a boiler. So when I am replacing this in a boiler in terms of fuel, what is the replacement of the carbon?
Yeah.
So you will need a similar footprint for the fossil fuel carbon mapping. Now, fortunately, I'll give you something again, since it's a specific question. There is something which is called as a EROI.
Yeah.
Energy ROI. It is a globally published number. What is energy ROI? Energy ROI is the amount of energy consumed in barrels equivalency for barrels equivalency of energy to be available with a consumer.
Okay.
So the initial, and if you look at data of this energy ROI, initial energy ROI numbers were 1:6, which means 1 barrel equivalent of crude is consumed for 6 barrel equivalent of product to be available to consumer. This number has now gone to 2:5. So 2 barrels of crude equivalent is consumed for 5 barrels of crude equivalent product to be available to us. That means we are going much more deeper, drilling newer wells, going deeper for coal because the tables are going down, and transporting it larger distance among continents. If Venezuelan oil is going to come from Venezuela to India, it is going to transport more distance from it coming from the Gulf. Now that transportation is going to cost us more energy.
Yeah.
So this energy ROI number is globally, and it is envisaged that this energy ROI number will move to 3:4. That means if we are so inefficient in the current fossil fuel energy that we are using. So that is a datum line. You will use that same datum line for now mapping the energy ROI in a decentralized system of 30, 40, 50 kilometers of this parali that you are moving. Yes, there is a carbon footprint that you have consumed, which today is fossil fuel. We need to change it also to cleaner form. We can talk about it. But using what you're doing presently and replacing that coal in the boiler or that LDO furnace oil, and when you map the energy ROI and the fossil fuel that you're using, this replacement will give you the number.
Perfect.
Of how clean or not clean you are. Does it make sense or not?
Yes, 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 yes. I
And when you
completely.
look at this energy ROI number, and we have done this mapping, so we
Mhm.
run a project for L'Oreal in Pune,
Mhm.
inside their factory where we have a boiler, where we have replaced a natural gas boiler which is coming from a pipe network. And when we did this energy ROI mapping and we presented it to them, and they got global third-party agencies from L'Oreal Paris to map it, the number came out that for every kg of biomass that we use and replace natural gas, we are reducing their 1 kg equivalent of CO2 footprint.
Perfect.
And the biomass here that we are moving is moving a 200-kilometer distance, because it is coming from Aurangabad to Pune in
Wow.
a system which is fossil fuel. But even then, we are reducing 1 kg equivalent of footprint. Now, if I am able to make that truck EV, if I'm able to make that tractor to be compressed biogas or EV, prove that that EV electricity is from a
Yes,
carbon
solar.
neutral source of
Yes.
solar, wind, battery energy storage system,
Mhm.
then this 1 kg footprint will be significantly higher. So
Yeah.
when you are going to do this mapping and tools that you are going to build, you will need to build the process of baseline first,
Yes.
and
Yes.
then the digital mapping. So suppose somebody is moving a tractor from, let's say, one field, so you have a geotagging there, and moving to a depot, which is again geotag. You know this tractor has moved with 12 tons of parali for a distance of 7 kilometers
Yeah.
on diesel, and hence this is the negative carbon footprint.
Sure, sir.
And
Got
that's the kind of process you will need to build in that. And
Okay.
again, these are solutions to build for DMRV, which you are doing, and your team and companies are doing. It is fantastic.
I just want to add something. So we did this calculation, like we did a pilot of say 1,000 ton in the last Parali season to save Delhi in our effort, in our way of efforts. So what we found that only 3% of the whole carbon emission is happening in the fuel. Like if we have to make a carbon project, the kind of carbon emission we are able to reduce through paddy based boiler is extremely large compared to the transportation. So that number is less than 3%. And we are in consultation with one of the carbon project making agency in Switzerland. So they said if it is less than 3%, you can ignore the transportation part. At
Yeah,
least
yeah.
this
So
is
that
what.
is exactly why I'm saying, because you are so decentralized,
Yeah,
you are
exactly.
utilizing that in a 30, 40, 50-kilometer
Exactly,
radius.
exactly.
Vis-a-vis, I gave you example of energy moving continents.
Yes, yes, yes. I
Obviously, you
completely
are
agree.
much more efficient.
Perfect, perfect. I got it. I got it. So I think this will have a lot of value if the local paddy is used in the local
Absolutely,
industry.
absolutely,
Then
and hence, the energy efficiency. So in a boiler, and we have done this study, you are about 17 to 20% more energy efficient than using fossil fuel because of this energy ROI. So you don't
exactly,
need any other metrics.
exactly, exactly. I
But
got
that is only one. Look at the other side of
it.
carbon replacement. And so
Yeah,
now what do we need to work? We need to convert these diesel tractors to CBG tractors.
exactly.
We need to convert these diesel tractors to EV tractors. And once you keep doing this, more and more additionality to that project will come, and hence
Yeah.
more carbon credit value.
Exactly. It's a wonderful, wonderful problem to solve. Actually, I'm part of Punjab government's subsidy committee for big machinery also. Like more I'm involving in it, I think it's just so much of problems to be solved
So,
altogether.
Professor Dhirasab, we can have a conversation offline,
Thanks.
happy to support.
Thank
We
you very
have an
much.
office in Chandigarh, Mohali. We have more than 70, 80 employees there, multiple projects,
Okay, okay.
across Patiala, Ropar, Bhatinda, multiple places in Punjab.
Perfect.
Again, we can happy to showcase and
Yeah.
have this conversation.
Sure, sir. Thank you very much. Yeah. Thank you.
Thank you for your questions.
Okay. The next question is from Mr. Suraj Aruna Devrao Tarak. I would like to know the efficient ways to collect farm residue and the cost of the final briquettes prices. Can we visit the manufacturing plant in Aurangabad?
So the simple answer to can you visit? Yes, we have plants in Punjab, Haryana, Rajasthan, Maharashtra, Karnataka, Goa. You can visit anywhere, more than happy. We allow visits across India. Thousands of colleges, students have already visited, government officials, potential private companies, entrepreneurs who want to do this business. more the merrier. So yes, you can visit. You can send us an email, send us a message, and we will facilitate the visit. Secondly, on the second part of the question, what does it cost? Costs vary. It is a function of the first mile transportation, etc. And transportation has a significant cost there. But as a thumb rule basis, the cost of farm agri residue, to build, let's take a standard size of 50 tons per day plant or 100 tons per day output plant of briquettes or pellets. If you have to work in this ecosystem, a project of a factory scale will cost you anything between 9 to 11 crores of a capital investment for the project itself. Outside of that, the supply chain management aggregation equipment will cost you another 3 to 4 crores. So overall, you would have a project in between 13 to 15 crores as a number to set up a 100-ton per day plant. Now, the cost finally of this biomass in a form that you aggregate, store, etc., and then for it to reach your project plant, at best should be in the range of about 3 rupee 50 paisa plus minus. Beyond that, it will not be economically viable to replace fossil fuel. Ultimately, you have to replace fossil fuel, and the use case always wants the energy cost to go lower. The conversion, capex recovery, etc., will be another about 2 rupees. So you would produce at your farm gate a briquette anywhere between 5 rupee 50 paisa to 6 rupees per unit. Then the transportation. Now, as much as distance you have to transport for the use case, but thumb rule basis, you can take that to be around between 1 rupee to 1 rupee 50 paisa per kg. So you are actually going to be able to supply briquettes, and obviously, you need to make some money in what you're doing, anywhere between 7 rupee 50 paisa to 8 rupee 50 paisa, 9 rupees per kg for the use case. So that's the kind of broad cost economics that will work. Again, ranging between 25 to 75 paisa variation, depending on the type of farm agri residue you use. Straw varieties would be slightly higher. Varieties like cotton stalk, soya, mustard would be slightly lower. Again, the moisture content of that biomass is a significant, variable. Do you need to put dryer systems to dry the biomass? And, those variabilities come in. But these are ballpark numbers to answer your question. I just saw one of my colleagues is on the call and he has put the Project 42 presentation on the chat box. So anybody who wants to download can do that.
Okay. Ms. Dolly Basson, please, can you ask your question?
I've been working in this area in the sustainability space for last 15 years. I'm an engineer by profession, and one of my focus area has been in terms of small and medium enterprises and tourism sector. In the tourism sector, in the tourism and hospitality sector, there are almost about 18% of the energy related cost for any operational unit. So it's very high as compared to in the traditional industry across the world, which is less than 7 to 8%. So especially when we come to India, most of the tourism places which are small, they are in the hilly area or they are in the rural areas. So there is very high energy costs there. So is there anything that you're doing on that area, especially addressing this issue? Because I drove a program long back to really bring in solar-based heaters and solar-based energy in the resort areas. And that really worked very well for most of this. But the problem is in terms of most of the hill stations, there is very little solar availability. So what are the other areas can be exploited, especially for this thing? And if there is any work which is done on this area with the technology that you're using, I'll be grateful.
Sure. So the energy use case that you mentioned, one use case is electricity, and that's where you are looking at the solar problem to solve. The second
Right,
use case is the energy for thermal use,
right.
where you're talking about geyser systems or centralized cooling systems. Again, for such resorts, there would be systems with food wastage, there would be system with plastic wastage, there would be systems for the cooking solutions. So there are multiple solutions which can be put in place for all these energy usage requirements of the resort to be given and independent of external energy uses. So when I say energy uses, external electricity, external requirement of energy for heating, cooling solutions. So in the resorts, you would need both. You would need heating solutions for warm water. You would need heating solutions for, let's take, saunas, etc., etc. You would need cooling solutions for AC systems. You would need, chillers. You would need cooking solutions, to be available. All of these can be done from various systems. There are gasifier solutions, there are boiler solutions which can be put in place, and these can be given. In terms of what can be put, depends on the scale and size of the resort. You can also do combined heat and power plant solutions to build. Now, where will it find a fit? It will find a fit for sustainability. It will find a fit for cost effectiveness. So if you look at cumulative costs of energy usage, electricity is one cost. But if you look at your LPG cost of in terms of the industrial LPG or the commercial LPG that you will buy, if you look at your cost of disposal that you're going to have for the waste that is generated, if you look at the food waste disposal which happens in these large resorts, if you look at the plastic waste which gets generated, all these can get utilized for energy solutions to be available. That energy can be for cooking, it can be for your thermal heating, it can be for your cooling, it can be for your electricity. And different scale and size, different projects can be done, or slightly mid-sized projects can be done integrated for the entire solution. The second part of the question, if we have specifically done it, we have looked at engagement with multiple such resorts, hotels, Taj, hotel resorts, which want to practice ecotourism, etc. However, yet we have not implemented anything at scale and size. But possibly, if there is some process where it needs to be looked at, more than happy to do that. Places which are slightly more remote. Let's take, for example, the Andaman and Nicobar Islands. Let's take, for example, the Lakshadweep Islands, today, which are becoming or getting developed as tourism hubs. The energy there moves from mainland to there. So the cost of electricity in Andaman Nicobar is in the range of 24 rupees per kilowatt hour and from fossil fuel. And we move that diesel from onshore to Andaman Nicobar to generate that. So, even if you look at multiple ways of solutions, you can do wonders in bringing the cost down and have sustainable solutions.
Thank you, sir. Thank you very much. I think these are very valid and very interesting points to really look at. I've been personally looking at trying to really look at agriculture waste. That's the reason why I asked if there is any, because agriculture waste and especially the food waste, which is getting generated in the fields as well as in the local ecosystem, can be basically used as an input towards this thing. So these are some thoughts that I had, but I haven't really worked extensively on this. We did work on solar, but not much on the other residue based work.
So we
So
can, have conversations offline. Happy to help,
agri-tourism is coming up in a big way. I've also been promoting sustainable tourism in the form of ecotourism as well as handloom tourism, especially with the focus of Northeast. And there is a huge requirement to really, and there is a lot of agriculture produce that is happening in that area. So that was one of the context that I posed the question.
Yes, it can be done. Definitely, it can be done.
Thank you, sir.
Okay, thank you. This is a question from Mr. Subramanya Prasad Surupaneni. Excellent, Ahuja ji. You have not only given sustainable alternatives and possibilities to be explored further, but also, like the Aurangabad case, quantified the benefits. Very optimistic indeed. SATAT scheme was introduced by the government in 2018, which inter alia expected about 5,000 CBG plants to be implemented across the country. Looking back, do you think we have achieved the desired results? I mean, are they enough takers, positive contributors?
So, the SATAT scheme is the sustainable alternative transportation. So basically, it is to generate compressed biogas or bio-CNG, which is the same molecule as the CNG, which is, being bought and going through the pipe network systems across India. So this is a scheme, yes, launched in 2018. The first, what the government had said was 5,000 projects of scale and size to be done of 15 tons per project and overall of 15 million metric tons of CBG generation and consumption to be done. At the end of the first 5 years of the scheme, the number of projects which were there on the ground were 48, less than 1%. So from implementation perspective and desired results, I think we failed miserably. But there are multiple reasons of why that situation. The upstream supply chain management of feedstock, the source separation of municipal solid waste organic fraction, the costs around it. The second part in terms of the midstream technological construction intervention of compressed biogas assets to happen, capital allocation there, banking sector to come in, conversion ratios depending on type of feedstocks, paddy straw to a conversion, cotton stock to a conversion, municipal solid waste to a conversion, the financial modelings around it and build up. All of that is progressive and happening. Today, where we have 172 of such CBG plants which are up and running. Unfortunately, most of them are not running to optimal capacity. Again, for various reasons. It's not that people don't want to run it, but the upstream supply chain management, costing, midstream asset management, the way they have been built. One must also understand that this is a biological chemical reaction. You're talking about bacteria to be consuming the substrate material in terms of the organic fractions of agriculture residue or municipal solid waste, converting it to gas, then looking at chemical processes for that gas, which comes in various forms to get upgraded to methane above 99.6% for it to get injected into a pipeline or moving in the cascade. And also then the market pricing at which this gas is to be sold, all of that is developing. But, again, I would like to be optimistic here. Government has recalibrated the target for the next 5 years from 2023 to 2028. So extended the Satat scheme. I don't think we will still reach the 5,000 because we are at 172 projects. We are already in 26, another about 2.5 years to go. But there is tremendous optimism across India for these CBG projects of Satat to come. The largest player in this segment today is Reliance. Mr. Mukesh Ambani himself in 2 successive AGMs has spoken about these CBG plants and what they are doing in this Satat scheme. They have signed up and it's a public announcement to do 500 projects in Andhra Pradesh on CBG generation. The announcements that Reliance has made is that they would do 1,000 projects pan-India. So, and presently also out of these 172 that I'm talking about, more than 56 projects are Reliance and 50 more are under construction at various stages. So large corporates like Reliance have got into this scheme. Adani is also there. All the oil marketing companies, public and private, are there, and many more are joining this Satat scheme. Still, there is a lot in terms of pricing, regulation, process, technology. Everything needs to be put in place, but it should happen. And overall, I would say from 100 marking number, we are at 2025. We can definitely move towards the 100. So that's on the Satat scheme as a response. I also read that there is a follow-on question, which is on carbon capture, where you've said that dominating global concerns in the pollution scenario in recent times, starting with dangers of SO2 emissions and particulate matter, etc. Again, I have spoken about carbon capture earlier. It is good that the first time that government has recognized that carbon capture needs to be done, at least in the Indian market. Funds have got allocated for it. So newer technologies of carbon capture will come in. We, from this domain, I spoke about biochar as one of the tools of carbon capture. We are also involved with a company called as Trace X Zero. This is again a startup. We have a MOU signed with them. We have published data and numbers in public domain where we are capturing CO2 from the stack. So any stack which is there, you have a negative pressure to pull and you can capture that CO2. And with the equipment and technology that Trace X Zero has built, we can convert this CO2 into graphite and graphene on site. And thus you would have carbon capture, storage, utilization, and a product which is marketable, which is amazing. So there are, startups, technologies which are coming up within India and globally for various carbon capture storage utilization projects. But I have also talked about, biochar, which is happening. Biochar can happen two ways. One is low tech Kentucky method, small investment, a couple of lakhs, and farmers and participate in movement, and you can do biochar and deployment. Biochar can also happen in science-based technological interventions of continuous plant, large-scale interventions. Both are happening in India. So, the more the merrier that, it can happen on the carbon capture utilization space. Thirdly, there are also technologies of direct air capture and carbon capture, which has got developed. IIT Bombay is one of the leaders in this. They have brought technology, they have brought solutions. These are getting, today implemented with refineries, large fertilizer plants, where large scale carbon capture storage, putting it into the ground, all of that is being talked about. Again, if there is a value for capturing that carbon and putting it into the ground, definitely there should be a higher value of converting it into a product and using it. So all these are happening. It's an amazing space to look at. You've talked about, vehicular emission. There are technologies today available to reduce this vehicular emission from the pipe systems to capture this carbon and convert it to a useful product. And such companies are, doing that. Widespread deployment is happening. It has already happened in a big way. It has become a law across every generator. So the generator exhaust, you are capturing 100%. That carbon soot is getting converted to a product to use, and you are reducing generator emission. Similarly, you can reduce the vehicular emissions.
So does it mean that the sulfur dioxide, which I was referring to,
Yes.
I don't have the statistics, but definitely this is a concern about sulfur dioxide and the other invisible pollutant, which is very
You are
harmful.
right, sir. So,
Yeah.
the
Maybe in this session, maybe it might be. I mean, I don't want to stretch because you're giving wonderful detailed answers, sir. But regarding sulfur dioxide, just what do you? I just want
So
to have
you're
your
right,
view
sir.
on that.
So, again, we had a program under the Honorable Supreme Court direction of flue gas desulfurization. These were to be put in every power plant to capture the sulfur dioxide. And, unfortunately, my view, we have reversed that to say that these are not required, and the large scale plants are producing sulfur dioxide and it is going into the air. So we have taken a step back over there, and, and again, it is based on the scientific community putting out data that it is not so harmful and hence it can be reversed. So something which came as a scheme, and few plants have already done it, and large scale capital requirement was there. Unfortunately, we have moved back on it. So personally, I kind of agree with a view that sulfur dioxide is quite harmful, and we need to have capture of that sulfur dioxide also along with the carbon, and differential usage. But unfortunately, I think it needs more attention.
Yeah, yeah. Thank you for that. Only thing is like it was the vehicles. The vehicles are growing exponentially every year, and Hyderabad is one of those cities where I live, and it's very emitting the sulfur dioxide.
So, sir, there is a committee under the chairmanship of Professor Ashok Junjunwala, IIT Madras, which was commissioned under the CAQM, Central Air Quality Monitoring, which is a regulatory body under Supreme Court Direction, Act of Parliament. And, Professor Ashok Junjunwala and the committee have recommended complete banning of internal combustion engine vehicles to be 100% replaced with EV in India, and the source of that EV or electricity to be from renewable electricity source only. This is very recent report. It is available in public domain. Completely path breaking, and the internal combustion engine industry, automobile industry is shocked. I've had this conversation as well. Here we are talking about CBG generation, CBG based engines, etc. And a committee under the leadership of such an eminent scientist has recommended India should move away from internal combustion engines at all. So, fantastic. And at least if that happens, why not?
Yeah.
So we have to see, right? We have to see the change of how it happens. And you cannot say in one go that entire automobile industry, what they have done, they need to shut down and convert. But fantastic that under Professor Ashok Junjunwala, such a recommendation has been made. So somebody will have to take cognizance of it, right? That, a government body, a government committee has made this recommendation.
Thank you, sir. Thank you so much. I think all these bottlenecks and all, which you have also brought out, and I think I would request Srivani Garu, I mean, on behalf of which I am also participant, that you do come to and visit both the Telugu states, and I think it will be lovely to have you, share your views with the who and who in the government.
Sir,
There are,
I visit Hyderabad often. And
yeah,
just to mention, I have a house in Secunderabad where I intend to shift and sit down. So I'm, shift there and move out of Bombay and come there. So hopefully I will be in your city, staying there very soon.
Yeah, and only just on a further note, just only one thing. I am a retired officer from Indian Oil Corporation. So, and let me tell you, sir, I believe Indian Oil is doing their bid for the green hydrogen fund. I'm sure you are aware, and I hope
Yes.
this better. Yeah. So wonderful, sir. Thank you so much. It was great interaction.
Thank you, sir.
With this, I'd really like to thank Colonel Monish Ahuja. That was for me, it was an inspiring talk. The country is moving towards sustainable energy, and it was very kind of you to come and really talk about it. This is the need of the hour. Thank you so much. And
Thank you so much, Shivani Madam. Thank you, WishwaTalks.